Good day, everyone. We are going to continue with our chemistry today, where we are going to discuss our questions. And after that, we will be talking about the rate of reaction affected by the concentration. Now, on the screen here, it is the question that I gave yesterday. I hope everyone have completed it. Now, an experiment is carried out to investigate the rate of reaction of excess zinc with this 50 cubic centimeter of hydrochloric acid, and the volume of gas collected at intervals are given to you. Now, can you see what is the volume, the maximum volume of gas collected here? Can you see the 30? The 30 is the maximum volume of gas collected. And what is the time taken for the reaction to complete? Is actually 5 minutes. Can you see here? The 5 minutes. Okay. Now state the meaning of the rate of reaction. Please check your answer. Rate of reaction is the change of physical quantity of reactant or product per unit of time. I repeat, rate of reaction is the change of physical quantity of reactant or product per unit of time. Okay. Now for the balanced chemical equation, I think you have no problem. We have already mentioned it many times, where you will have 1 mole of zinc reacts with 2 mole of HCl. You are getting zinc chloride and the H2. Now, if you are still not sure about the chemical equation, this is your answer. The zinc reacts with HCl, giving you the zinc chloride plus hydrogen gas. Put a 2 to balance up the equation. Okay, next part. We are now doing gas.
Ranjani is waiting to join.
Go on. Okay, now continue. Here, next part. Now, next part, from the graph, determine the concentration of hydrochloric acid used. Okay, now, what is the meaning of concentration? The concentration means we are going to calculate using the unit mole per decimeter cube. Okay, now from here, when we are writing our chemical equation, this one, the ZnCl2 plus H2, the volume of gas released will be 30 centimeter cube from the graph. Do you agree? Okay, now we assume that all the HCl completed reaction, and this is 50 centimeter cube. I mentioned to you before, when we are having problem to calculate, we are always going to start from the first step, which is the number of mole. And in this case, we are going to calculate the number of mole of the H2, because we have already know about the volume, which is 30 centimeter cube. Now, if you are talking about 30 centimeter cube, you have to change it to decimeter cube so that you can divide with this number. So it will be, moving to the front for 2 places, 1 to 0.3 decimeter. Sorry. 3 places are 0.03 decimeter cube. Okay, we should be getting 0.03 decimeter cube. Okay, so here we should change to become 0.03 decimeter cube divided by 24 decimeter cube per mole. Someone press your calculator for me. Tell me your answer. What's your answer? Anyone?
0.00125.
Mine is some, okay, 0.00125 mole. Okay, good. Now we continue on. When we are having 0.00125 mole, can you see the ratio of hydrogen is to HCl will be 1:2. So the number of mole of hydrogen that we have calculated just now was this. So how much of HCl? What is the number of mole of HCl? This one you are going to take it to multiply by 2. So what is your answer? Someone 0. Your calculator is not with you.
0.0025.
This is Lokachun, is it? Okay. So
yes, teacher.
thank you. So your answer will be 0.0025 mole. Okay. Now, our question wants us to calculate the concentration. Okay, I'm going to use other color. I'm going to use the orange and I'm going to put it here. Now, from here, the 0.0025, it means that the number of mole of HCl equals to 0.0025 mole. Meaning to say, if I calculate MV over 1000, it will be equals to 0.0025 mole. Now the M is something that we are looking for. The V is 50 from our question. Okay, someone press your calculator. How much is M? You're actually taking this 0.0025 multiplied by 1000 divided by 50. What is your answer? Someone?
0.05.
0.05. Okay, now we know that this M is the concentration. Therefore, the unit will be mole per decimeter cube. Okay, now again, this is 3 steps calculation. I'm going to summarize for you how do I get the 3 steps. Number 1, we calculate the number of mole from the volume of the hydrogen gas obtained. Then we go on to the next step, which is the ratio. And the last step, we are going to relate back to the number of mole to the MV over 1000 in order for us to get the M. Okay, I hope you are with me. Are you? If you are okay, you please show a like. Are you okay, everyone? Okay, no problem. Okay, good. Thank you. So now we are going to move on to the next part of the question. Thank you. Next part. We are now going to clear this off first, and now the next part. The average rate of reaction. So how are you going to calculate? Yesterday we mentioned the average rate of reaction will be the volume divided by the time taken. So the volume divided by time taken. Therefore, it will be 30 centimeter cube. Time taken is 5 minutes. Please check again from the graph. Did I do it correctly? I hope it's correct because I don't see the graph here. So it will be 6 centimeter cube per minute. Is it okay? You can change to decimeter cube, no problem. You can change to second, no problem. But you have to make it the unit which is correct. If you change this to second, then it will be per second. Of course, the value that you divide, the value that you obtain will be different. Okay? Now, next part. Based on the collision theory, explain why does the rate of reaction decrease with time. Okay. Now, initially, when we are having the reaction just started, we will have a lot of many of these reactants. We are using the word concentration to describe. Now, when time moves on, some of these reactant has reacted. Now, what are those reactants which are taking part in the collision? Yesterday, I talked about the collision theory, where from the chemical equation, we are going to write the ionic equation. So from the ionic equation, we will find that the zinc atom will collide with the hydrogen ion to form the zinc ion and the hydrogen gas. This one I don't show again because yesterday I've already shown you. Now, this is the part that will determine whether the reaction will go very fast or will go very slow, because the zinc in this case is in excess. So this one will affect the rate of reaction. Initially, you have a lot of this hydrogen ion. From where you get? From the acid. Okay. As time moves on, the concentration of the hydrogen ion decreases. That is the reason why the rate of reaction decreases with time. Okay. So your answer, as time moves on, the concentration of hydrogen ion decreases. The frequency of collision between the zinc atom and the hydrogen ion decreases. The frequency of effective collision between the zinc atom and the hydrogen ion decreases with time. 3 sentences. I repeat, first you talk about the concentration of the hydrogen ion decreases. Second, talk about the frequency of collision between the zinc atom and the hydrogen ion decreases with time. Then relate to the frequency of effective collision between the zinc atom and the hydrogen ion decreases with time. Okay, now I hope you are with me. Next part. We are now going to move on to talk about the experiment where it is repeated using the sulfuric acid of the same volume and the same concentration. Okay, now I have a question. What can you tell about the sulfuric acid? Anyone? Can I hear from Faith? What can you tell about sulfuric acid?
It's an acid.
What acid? Sulfuric acid compared to the hydrochloric acid. What's the difference between them?
Stronger acid.
Stronger. We don't use the word stronger to explain, to describe. No.
Diprotic acid.
Yes.
Diprotic acid.
What is the diprotic acid?
Sulfuric acid.
Okay, correct. The sulfuric acid is the diprotic acid. Okay. And the hydrochloric acid is the monoprotic acid. Now, what do we mean by diprotic acid? Meaning, for here, I'm going to write here, if we are having H2SO4, it will dissociate to form 2 mole of hydrogen ion. Okay? Now, when we are having the hydrochloric acid, it will dissociate to form 1 mole of hydrogen ion only. Just now, we have calculated that our number of mole of hydrochloric acid will be 0.0025 mole. Okay? Therefore, 1:1. The number of mole of the hydrogen ion is also 0.0025. But in the case of using the sulfuric acid, this has doubled. Can you see? The ratio is 1:2. 1, I should not use the rate, sorry. The ratio is 1:2. Therefore, when you have that much of number of mole of sulfuric acid, the hydrogen ion will be doubled, which is 0.005 mole. Okay? And which one will have a higher rate of reaction? Can someone tell me? I'm going to use the whiteboard now to show you. Since some of you might confuse with what we have talked about it yesterday. Yeah. Okay, now this is, assume that this is the graph. Okay, assume that this is the graph that you have initially from the question. This is the graph. Okay, now this is using the HCl. Now just now I said when you have H2SO4, the concentration of hydrogen ion is higher. Therefore, what will happen to the rate of reaction when the concentration is higher? Shall we hear from Jasnick? When the concentration of the hydrogen ion is higher, what happens to the rate of reaction?
It increase.
Sorry?
Increase. It increase.
Decrease or increase?
Increase.
Yes, it will increase. Thank you. Now, when it increase, meaning the line here will be higher than the line of the pink. I'm using the blue. So this line will be higher here. Okay. Of course, it should be a straight line. Okay, it should be a straight line. Now, my problem is, will they meet at the same height? We are going to calculate the volume of hydrogen gas release. Why do we calculate the volume of hydrogen gas release? Because we are plotting the graph of volume of gas versus time. Okay, this is the graph on the volume of gas versus time. Now, everyone calculate for me, what is the number of mole of the hydrogen gas produced in the experiment using HCl? When we are using HCl, the number of mole, the question already given us, when we are using HCl, it is 30 centimeter cube. So now when we are using sulfuric acid, the number of mole of H2SO4 equals to how much? It is still the same, 0.00125, agree? Sorry, refer back to your chemical equation first. Okay, now you are having the chemical equation as zinc react with H2SO4. You should be getting ZnSO4 plus H2. Okay, now look at the ratio. H2SO4 to H2, it is 1:1. Now, previously in our first experiment, someone please tell me what is our number of mole of this HCl? You refer to your notes, please, just now. 0.00
25.
0.0025, is it? So now when we are talking about H2SO4, since the volume and concentration is the same, then we are still getting 0.0025 mole. Okay. Now the ratio of the H2SO4 is to the hydrogen gas, it is still 1:1. So 0.0025 is to 0.0025 mole. And when we are talking about this 0.0025, it will be double than that from what we have of the HCl. Why? Because initially in our zinc react with HCl, we are getting actually 0.00125 mole of hydrogen gas. Okay, so now when it is double, meaning this one will be higher here. And if I am drawing like this, it is wrong. Why is it wrong? Because this one and this distance here does not show double. Okay, so how should you do? Let's say this is your let's say this is your axis, okay, Okay, now you have another line here. This is the one using the H2SO4. The pink is the one using H2SO4. So now, the blue one is using the HCl. The pink one is the one using H2SO4. This part, you erase the one. Okay, now, can you see the distance from here to here and from here to here is almost the same? Therefore, this is your answer. Okay, now go back to our question just now. This is our question. If they ask you to plot on the graph, meaning this is the graph, and where will it be? Your line will be up here. The blue one, it will still start from the origin. Okay, and you label this as 60 because double. And this one, you label this one set to using the H2SO4. Okay, of course, my graph is still not the perfect. Can you see the distance? Can you see the distance? Okay, so you please check. Okay, so this is our question 2. Any problem? I hope you are okay. Okay, now we are going to move on to our question 3. This question 3. Now, experiment is carried out to determine the rate of reaction between the calcium carbonate and the dilute hydrochloric acid. This is the table given to you. Balanced chemical equation, calcium carbonate with the dilute hydrochloric acid. I hope you still remember this. Your answer should be CaCO3 hydrochloric acid. You are getting CaCl2 plus CO2 plus H2O. Balance up the equation. Okay. Now, based on the result, you plot the graph against time on the graph paper. When you are using the graph paper, meaning you are plotting. Okay. Now, how do you get your marks for your graph? Number 1, you check your axis here should be labeled as volume of gas with the unit. The time follow here, second, so with the unit second. Put all this dot, the time here 0, so this is 30, this is 60, and so on until 270. The volume, you are going to put your this one scale. Let's say you want to put from 5, so 5, 10, 15, and so on. Okay, then you plot. You will get a smooth curve going up like this. Okay, so make sure you get all this. Now they want you to get, by referring to the graph, you calculate the rate of reaction at, can you see at 120 seconds. Now at means it is the instantaneous rate of reaction. Therefore, you are going to get, or let's say this is 120 seconds. Follow the rate one. Let's say this is 120. This is the point. So you are going to get a tangent that touches this point X only, touch. Then you draw the triangle, get the coordinate X1, Y1, X2, Y2. Then you are using the formula Y2 minus Y1 over X2 minus X1. And your answer, last answer, the unit will be in centimeter cube per second. Okay, this is instantaneous rate of reaction. Now move on. You are going to sketch the curve that would obtain if the experiment is repeated using powder calcium carbonate. Replace the powder to the granules. Okay, now the keyword here, the powder initially change to the granule. Okay, Now, what can you say about this powder and granule? Powder means a small size. Okay. Granule means bigger size. Now, when we are talking about this, meaning we are talking about the factor, the size. Size of who in this case? In your book, they will put it as size of reactant. But then we have to answer specifically to the question. It will be the size of calcium carbonate. Okay. So for the table that you have drawn yesterday, you put the factor as size of reactant. And for this case, to be specific, it will be the size of calcium carbonate. Now, what is the keywords? The keywords will be the total surface area exposed. Total surface area exposed, the keywords, okay? Meaning, when it is having a smaller size, the total surface area exposed is larger, okay? You imagine you are taking this one piece of eraser. This is a big piece. When you don't cut it, the total surface area exposed to the reactant will be only here, 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 and the faces that you don't see. The below, the one behind, and the one on the left. If you cut this, cut, okay, to a smaller pieces, then you are actually increasing the total surface area exposed. Therefore, when the size is small, the total surface area exposed is larger. When the size is bigger, the total surface area exposed is smaller. And it is telling that when we are using a bigger size, we are actually having a lower rate of reaction. Okay. Now, this question wants us to sketch the curve that obtained when we replace using the granulated calcium carbonate. So what can we do now? Okay. We are going to go up to the graph there. We know that the graph that you obtain, let's say the graph that you obtain is this. Let's say this is the graph that you obtain, this one. Okay, this is using the powder CaCO3. We know that when we are using the granulated calcium carbonate, the rate of reaction will decrease. Therefore, we are going to obtain a line which is lower than this, which is somewhere around here. Okay, and other conditions are remain. Therefore, the volume of gas released, at last, it will be still the same. And it will reach at the same height of the graph here. Okay, I hope you understand. So this is about the sketching of graph. Okay, now based on the graph in B1 and the curve in C1, explain why there is a difference in the rate of reaction by using collision theory. So now, we just now said it is changed to use the granule calcium carbonate. So the rate of reaction when using granulated calcium carbonate is lower. Reason? The size of calcium carbonate of the granulated the size of calcium carbonate or the size of granulated calcium carbonate is larger. The rate of the total surface area exposed of the granulated calcium carbonate is smaller. Then we talk about the collision between what and what. Again, we have to get the particles which collide. Now, from our chemical equation, we are having CaCO3 to react with the hydrochloric acid to give you these substances. Now, as to write the ionic equation, this calcium carbonate is a solid, so we write that. This is a solution, so we are going to separate it. Calcium chloride is a solution, separate. The gas and the water molecule, we write that. Now, what are the same on the left and right? They are the chloride ion. Sorry, this is the chloride ion, so we cancel it off. Now, what is left will be this. Okay, this is the ionic equation. These two particles are the one which is collide. Therefore, after we talk about the factor, the size of granulated calcium carbonate is larger. The total surface area exposed of granulated calcium carbonate is smaller. Then we talk about the frequency of collision between the calcium carbonate and the hydrogen ion is lower. Therefore, the frequency of effective collision between the calcium carbonate and the hydrogen ion is lower. Okay, I hope you can understand. Any problem until here? If you have any problem, please unmute and tell me.
So you can repeat the last sentence, Acha.
Which part?
The frequency of effective collision.
The frequency of effective collision between the calcium carbonate and the hydrogen ion is lower. Okay? Now,
Thank you, Acha.
from the beginning until now, we have actually mentioned about two factors, okay, which is the concentration of solution or the concentration of the reactant. And the last question just now, number 3, we were talking about the size of reactants. Okay, I hope you can understand until here, and we will move on to the next part of our lesson.